Hi students, we are going to see Cauchy's residue theorem. If f of z is analytic at all the points inside and on a simple closed curve C, except at some isolated singularities z1, z2, etc. zn, then by Cauchy residue theorem, integral over C f of z dz is equal to 2 pi I into sum of residues of f of z at z1, z2, etc. zn. Already we have seen how to find residues. Keeping that, we are going to solve this problem. Evaluate integral over C z minus 1 divided by z plus 1 the whole square into z minus 2 dz, where C is a circle mod z minus I equal to 2 using Cauchy's residue theorem. First, let us consider f of z. F of z is equal to z minus 1 divided by z plus 1 the whole square into z minus 2. To find the singular points, you need to equate the denominator to 0. That is, z plus 1 the whole square into z minus 2 is equal to 0. From which we can define the pole and order. Now, z is equal to minus 1 is a simple pole of order 2. And z is equal to 2 is a simple pole of order 1. First, before moving on to residue, only if these poles lie inside the circle, they have residues. If they lie on the circle or outside the circle, the residue becomes 0. So, to check that, we consider the circle mod z minus I is equal to 2. We already know how to find the circle equation. So, we take it as modulus of x plus iy minus I is equal to 2. Equating real and imaginary, you get the circle equation as x square plus y minus 1 the whole square is equal to 4. From which the center is 0, 1 and radius is 2. So, keeping center as 0, 1, x is 0, y is 1, center is here, and radius as 2. So, radius as 2 means the circle passes through 3 and minus 1. So, I have taken a circle. And now when you see for the point z is equal to 2, it will come outside the circle. So, therefore, when it is outside the circle, residue of f of z at z tends to 2 becomes 0. So, residue when it lies outside or on the circle, it becomes 0. So, you need to find out residue only for z is equal to minus 1. Now, residue of f of z at z tending to minus 1. Here, the order is 2. So, we already know the formula. It is 1 by m minus 1 factorial limit z tends to z naught d power m minus 1 dz power m minus 1 z minus z naught f of z. Substituting in that, you get it as 1 by m minus 1 2 minus 1 factorial limit z tends to minus 1 d power 2 minus 1 dz power 2 minus 1 z plus 1 the whole square f of z. Instead of f of z, replace it as z minus 1 by z plus 1 the whole square z minus 2. Z plus 1 whole square, z plus 1 whole square gets cancelled. We have it as limit z tends to minus 1 d by dz z minus 1 divided by z minus 2. You need to differentiate this using u by v differentiation. U by v formula is v u dash minus u v dash divided by v square. Same thing I have done. Z minus 2, z minus 1 differentiation is 1 minus z minus 1, z minus 2 differentiation is 1 divided by z minus 2 the whole square. You need not simplify this, just substitute the limit as z tend to minus 1. Instead of z, replace it as minus 1. So that you get it as, instead of z, if I substitute minus 1, it becomes minus 3, minus of minus 2 divided by 9. So you get it as minus 1 by 9. So I have residue of f of z at z tends to minus 1 as minus 1 by 9. Therefore, by Cauchy residue theorem, integral over C f of z dz is equal to 2 pi I into sum of residues. That is 2 pi I into minus 1 by 9. I have taken only one residue since the other residue is 0. Therefore, it becomes minus 2 pi I by 9.